Hello guys! In this lesson we are going to talk about how to find the sum of infinite geometric sequences. Before learning the infinite geometric sequences formula, let us recall what is a geometric sequences. A geometric series is the sum of sequences wherein every successive term contains a constant ratio to its preceding term. An infinite geometric sequences has an infinite number of the term and can be represented as ar squared to infinite. Let us learn the infinite geometric series formula. The general formula for finding the sum of infinite geometric sequences is S equal to B1 divided by 1 minus Q, where S is the sum, B1 is the first term of the sequences, and the Q is the common ratio. The geometric series converges to a sum only if Q less than 1. If Q greater than 1, the series doesn't converge, and it doesn't have a sum. To find the common ratio, use the formula Q equal to B2 divided by B1, where B2 is the second term in the sequences, and B1 is the first term in the sequences. All the characteristics of a person are related to each other. If his spiritual soul is rich, then he will have many moral qualities. On the other hand, if unfairness prevails over negative traits, that person is considered to have other negative traits. So, let's say if it's 8 plus 4 plus 2 plus 1 plus a half plus 1 over 4 and then continues forever. How can we find the sum of infinite geometric series? There is a formula for this. The sum is going to be equal to first term divided by 1 minus Q, where Q is common ratio and the formula works if the absolute value of Q less than 1. So, in this example, the first term is 8. Now, what is the common ratio? To find the common ratio, take the second term and divide it by the first. So, 4 divided by A is a half. To confirm it, take third term divided by second. 2 divided by 4 is a half. So, to take the next term, you got to multiply by a half. 8 times a half is 4. 4 times a half is 2. 2 times a half is 1, and so forth. So, the common ratio, which is 1/2, is indeed less than 1. So, therefore, we can use a formula to determine the sum of series. Will converge to a specific value. If Q was greater than 1, then you cannot find the sum of this infinite geometric series. It can keep getting higher towards the positive values or keep getting lower towards the negative values. So now let's finish this problem. So B sub 1 is 8 and Q is a half. So (3 plus 2 plus 4 over 3 plus 8 over 9 plus 16 over 27, and so forth. What is the sum of the infinite geometric sequences? So, we can see that the first term B sub 1 is equal to 3. Now, what about common ratio? So, let's divide by second term by the first term. So, that's 2 divided by 3. Now, just to confirm, has to be the same. So, we need to check the third term divided by the second. So, if you take 4 over 3 and divide it by 2, that's going to give us the same value. If you multiple the top and the bottom by the 3, 4 thirds times 3 is just 4, and 2 times 3 is 6. 4 over 6 reduces 2 over 3. So we do have a common ratio, and since the common ratio is 2 over 3, the absolute value of q is less than 1. Repeating, so we could find the sum of the infinite geometric sequences using this formula. So it's going to be 3 divided by 1 minus 2 over 3. So in the sequences, our answer is 9. Now, sometimes the infinite series may be presented in summation notation. So, if it's given to you like this, how you can find the sum of the infinite geometric sequences? Well, you can begin by listing out the terms. So, if you plug in 1 into the sequences, 4 over 5 raised to the 1 minus 1, that's going to be over 4 over 5 raised to the 0. Power the anything raised to the 0 power is 1. So the first term is 1. Now, to find the second term, you need to replace n with a 2. So it's going to be 4 over 5 raised to first power, which is simple 4 over 5. And then the third term is going to be 4 over 5 raised to the 3 minus 1, which is 2. So 4 squared is 16, 5 squared is 25, and so pattern will emerge. If you plug in 4, this will be 4 minus 1, which is 3. 3 4 to the third is 64, 5 to the third is 125. So you can begin by listing out the terms, and then you can determine what the common ratio is. So if you take the second term divided by the first, you can see that the common ratio is 4 over 5. And the common ratio is going to be the number that's raised to the n or the n minus 1 power. So you could see it right here. The first term we could see that it's clear 1. And because the common ratio is less than 1, we can use a formula of determine the sum. So it's going to be 1 over 1 minus 4 over 5. Now, let's say if you don't want to write out the sequence of partial sums, how can we determine the first term and the common ratio? This is formula. And for the series with the sequences, b to the q raised to the n minus 1, the sum is over 1 minus q. So basically, this b is the first term and so we can see that this formula is in appropriate form. And the number that's in front of the 4/5, it's invisible, so it's an invisible one. So you could see that B is 1 and the Q is 4/5. Notice that everything else matches. N is 1 and we have n minus 1 on top.
So guys, that's all. I think this video was useful for you. Thank you for attention. Goodbye.